Gas Laws, Lecture 8, Dalton's Law of Partial Pressures. So what Dalton was observing with the law of partial pressure is mixtures of gases. So let's say that we in a container of air, okay? We know in air we've got many different elements, so let's say we're just observing that we've got some oxygen molecules, okay? So we know they're going to exert a pressure. They're moving around in the container. And let's say we also have in the container maybe some nitrogen. Okay, what Dalton observed is that each of these different gases are going to exert an individual pressure. So oxygen's going to exert a pressure in the mixture, and so is nitrogen. Nitrogen's also going to exert a pressure. So what he said is that we can add all of those pressures up of our gases, our individual gases, we can add them all up to equal the total pressure. So in this example, it would be the pressure, or total pressure would equal the pressure of oxygen plus the pressure of nitrogen. And we would get a total pressure. Okay, let's do a practical application of this. Let's say that we're going to collect a gas over water. So we'll say that a gas is collected over water at 20 degrees Celsius. Okay, and we know that the total pressure is 770 millimeters of mercury. Okay, at 20 degrees Celsius, if we're collecting it over water, we're going to have a vapor pressure, a pressure of water. The vapor pressure of water, so we'll say that the vapor pressure of water is, and we'll say, if we look that up on our table, the vapor pressure of water is 17.5 millimeters of mercury. And we want to know what is the pressure of the gas. So even if we don't know what the gas is, we can still determine its pressure. Okay, so according to Dalton's law, he says that we can add up all the pressures of the gas to get the total pressure. So in this problem, if we're collecting it over over water, and we're going to have water in the container. Okay, as we start to collect the gas, so it goes into the container, the amount of water is going to be reduced. Okay, but the problem is that if we're collecting it over water, we know that water naturally evaporates. So we're going to also have the pressure of our water molecules in the gas form plus the pressure of our gas. Okay, so the formula for that would be the total pressure that's being exerted will be the pressure of our gas plus the pressure of water, so the vapor pressure of water. So if we go back in our problem, I gave you the total pressure. Okay, our P total is right here. And I also gave you the vapor pressure of water. So the pressure that water is exerting is 17.5. Okay, so if we plug these into our equation, we're going to have 770 millimeters of mercury equals the pressure of our gas, which is our unknown, plus the pressure of water, so the vapor pressure of water, which is 17.5 millimeters of mercury. Okay, to solve for the pressure of gas, we're going to subtract the two. 17.5 is going to cancel out. Subtract 17.5. So we're going to get, I'm going to pull it up here. So the pressure of our gas is going to equal 752. Okay, and our units were millimeters of mercury, so it needs to stay in millimeters of mercury. Okay, so overall, what Dalton's law is saying is that if we've got a mixture of gases, that total pressure is the summary or the sum of each of the individual gas molecules. So it's going to be the pressure of the gases in the container.